So knowing that carbon dioxide is the product of this reaction, calcium carbonate, write a balanced chemical equation for this process. So the question then becomes, well, do we get anything else out? Are we accounting for another chemical? There's all these other questions and you may not know where to start. So like I always say, just write down the things that you do actually know. We know that there's calcium carbonate, there's heat, and we know CO2 has come out because we did the flame test and we did the lime water test. So we know that this and this both exist. Now the question then becomes, well, what is the question mark? So from looking at the chemicals, 1 carbon atom and 2 oxygen atoms are consumed. So we don't need to worry about this, and we don't need to worry about 2 of these. So there's only 1 left. So what could be left over possibly? So the only things that are left over are a 1 calcium atom and an oxygen atom. And it's very likely that because they're already bonded together, because it's in the CaCO3 molecule as a whole, because they're already bonded together, it's likely that they'll stay bonded together. You'll get CaO as your other product. And the way to test that is to see if when you dilute it in water, when you dissolve it in water, if you get a basic solution out. If you do, you may have gotten CaO. Okay, so for the people that like baking, sodium carbonate or sodium bicarbonate, but we'll just say sodium carbonate for simplicity, is often used in baking, and its purpose is obviously to make the cake rise, and also bread, so leavened bread. From this investigation, explain why sodium carbonate raises bread and cakes. So why? Now that we know what the decomposition of a carbonate looks like, why does it make bread rise? 2 things look like very unrelated topics, but really, if you think about it very carefully, they are actually the same thing. Remembering that when you bake things, you put it in an oven, so it gets hot. So in the heat of the oven, sodium carbonate decomposes in a similar way to calcium carbonate. Now that decomposition produces CO2. Now if the sodium carbonate is well distributed through the mixture, so if you've mixed your dough very well, then the CO2 produced will create lots of little bubbles in the cake. And those little bubbles obviously take up space. By taking up space, they make the bread or cake rise. That's under the assumption, of course, that you've distributed it well throughout your system, you've mixed your dough very well, and so that's why cakes rise when you add this sodium carbonate or sodium bicarbonate. And essentially, that's the only difference between flour and self-raising flour. They add a little bit of sodium carbonate or sodium bicarbonate into your flour mixture. That causes it to rise. Question 13. Given that sodium carbonate has the formula Na2CO3, write a balanced chemical equation for the decomposition by heat. So the same thing, we start with what we know. We know we get CO2 out because we just talked about it in the previous question. Now all we need to know is what this question mark is. So the chemicals remaining are 2 Na atoms and 1 O atom. So we've only got 2 Na atoms and 1 O atom. The valence of Na is 1 plus and the valence of O is 2 minus. And therefore the remaining product must be Na2O. Now that makes sense again because if it's already bonded together, it's likely to stay that way if just 1 carbon dioxide has been removed. That's probably a good place. You just write it out. Now if you look through the balancing, you've got 2 Na here, 2 Na here, so that's good. 1 carbon here, 1 carbon here, that's again good. 3 oxygens here, 1, 2, 3 oxygens on this side, so it's all balanced. And that works out very well. Explain why the lit match test can identify the presence of CO2. So how does the lit match test actually work? Well, combustion requires the presence of oxygen or another oxidant, right? It needs to have some kind of oxidant to allow the flame to burn. Now, CO2 cannot provide oxygen to the combustion system and only serves to absorb the energy emitted by the flame. So the flame is actually emitting energy. What happens is that energy would usually go into breaking up oxygen molecules. But all the CO2 is doing is just sucking up that energy and not leaving it to break up more, and doesn't even break up. You're not getting any new reactants, so it's just absorbing energy from the reactions, and you're losing reactants. It just quenches the flame essentially, and that causes the flame to extinguish. Because it's absorbing all the energy the flame is emitting, and not breaking up into oxygen molecules, then you can't have any more flame because all the energy is gone. So that's why carbon dioxide puts out fire. So we're going to look at now the other tests for carbon dioxide, the lime water test. In this question, if lime water is given the chemical formula CaOH2, and in the presence of carbon dioxide, CaCO3 is produced, calcium carbonate, write a balanced chemical equation for the reaction between CO2 and lime water. We're actually going to look at what is the actual chemical reaction that's happening when carbon dioxide hits lime water. So from the question, again, as I always say, just write down the things that you do know. And if you don't know this equation, then we'll just derive it from sort of first principles. All you have to do is write down the things that you know first. We know that there's going to be calcium hydroxide, there's going to be carbon dioxide as our two reactants. They're the two things that are going to make the cloudiness happen. And we know that CaCO3 is produced because the question tells us that. Now the calcium and carbon dioxide are both accounted for in one of the products. So calcium here, carbon dioxide here is accounted for in this product. So we don't need to worry about that. No need to worry about those two. As well as one of the two oxygen atoms. So there's two oxygen atoms here in the two hydroxide parts. So we can cancel one. But what's left? You've got two hydrogen atoms and one oxygen atom left over. So if you've got two hydrogen atoms and an oxygen atom, two hydrogen and oxygen, H2 and O, it's pretty logical that the other thing must be water. Okay, because we didn't see any gases being produced. We didn't see any sort of acidity. We can't assume that. So the best thing to do would be is probably water. So we'll just make water as well. So the final reaction is down the bottom here. So instead of a question mark, all we've got is water. If we were to try and insanity check ourselves, you've got one calcium, one carbon, one carbon, 2, 4 oxygens, 3, 4 oxygen, 2 hydrogen, 2 hydrogen. So it's all balanced. So again, this may not be the hardest question in the world, or if you didn't know this, at least you do now. But it teaches you that if you just write down the things that you do know, it becomes very obvious what the answer should be. That concludes today's lesson on the first-hand investigation for a thermal decomposition of a carbonate, which is quite a mouthful. And it also concludes our series on physical and chemical change. So hopefully in this time you've learned how to distinguish physical and chemical changes, and you've learned more about the decomposition of a carbonate. So I look forward to seeing you at our next lesson.